All right, so we should be here on page 8. If you recall, yesterday we watched a couple of those videos. We looked at all the pictures of where were we? We were on gravity erosion yesterday. What were some things? So we need to go through these big ideas for gravity erosion. What were some of the things that you noticed with all those pictures, with all the pictures, all the videos? What was one thing that stood out to you with gravity erosion? Okay, so definitely had to do with mountains and hills. So gravity erosion does move stuff from higher elevations to lower elevations. Absolutely. What was some other things that we noticed throughout those videos? Yeah, Dakota. It was big rocks and little rocks. It moved. It wasn't discriminatory. It didn't matter. That's the word. It didn't matter what size. It moved whatever was on the hill, from the top of the hill to the bottom of the hill. What were some other things, or wasn't there much else that you noticed? Take a look at the shape of these rocks. What's one thing you notice about the shape of the rocks that are at the bottom of the hill? They're jagged. In earth science, we typically call that angular, but that is something to notice. It's something, if I was to hand you a rock, you should notice it's jagged, and you could say it could have been weathered and eroded by gravity then. So I think you got most of the idea there. So in the big idea box for this, these are the things you need for gravity erosion, the big ideas. So as we said earlier, gravity is the driving force of all agents of erosion. Like Zach said, gravity pulls sediments downhill. And both things that Dakota said, sediments can be any size. They're typically angular. And then I did add in there that they're unsorted. We'll talk about that once you guys are done. Okay, so the big thing that we do need to make sure that, and I kind of just threw it in here at the bottom, is that the sediments are unsorted. What do you think I mean by unsorted sediments? Good. That's a good way of putting it. There's no pattern to the sediments at the bottom of the hill. So I'm going to go back to this picture again. So when you're looking at this pile of sediments, there is no pattern. And what do you mean by pattern? Like, they're not arranged in any particular order. It's not all the big sediments over here, all the little sediments over here. They're not arranged by height or size. So in this case, they're all jumbled up. So unsorted, just like if you were just to take all the clothes that you have on the floor of your bedroom, right? Because you guys don't use hampers, right? You're not. I am not surprised. Sorry. he cleans up my room here for me, so I'm not surprised you use a hamper. But the rest of us probably have all of our clothes all over our bedroom floor. No, you neither? So wait, are you guys all weird like this? Do you all use a hamper?
Hey, hamper, I don't think hampers are weird, I think they're necessary.
Oh, she gave you a hamper? Oh, you must have been so thankful.
Yeah.
Do you use it? Oh, I'm proud of you.
I don't.
I no, that's where I was going. I'm not saying my floor of my bedroom is clean. Let me rephrase this. I just recently turned my kids' old playroom into my own closet. So there is no clothes on my bedroom floor anymore. But that whole other room is a mess. But what? You're judging, aren't you? He's totally judging me. Yes.
No, you know, I heard this from my mother. My mother told me, you know, and this is something her mother told her. You know what happens when we assume? It makes an ass if they do it.
Yeah.
Anyways, I'm not judging you.
Okay.
I try not to judge.
Good. So let's just move on. All right. He's not judging me. He's not judging any of us, for the record. No, he's not. He just wouldn't live like us savages. All right, moving on. So I think we've established what unsorted means. Unsorted is when everything is just a pile of mess. You've got, yeah, not me, myself, just my clothes. That's all. So, unsorted, where I was going with this, where I brought in laundry to the whole situation. I think a lot of you have at least attempted to do your own laundry at one point.
Yeah.
Oh, that sounded fake. Hopefully, yes.
So making one big ball now.
Yeah, that is a perfect example of what unsorted means. So I hope you guys know that you don't want to mix your new red shirt with your new white shirt and put them both in the laundry at the same time, because you're going to come out with a red shirt and a pink shirt then. So where I'm going with this is when you do laundry, you typically sort your laundry by colors. Maybe a light, no? You just don't have any white clothes that are red clothes then. There we go. Yeah.
My mother sorts by times and not.
Oh, your mother's like my mother-in-law.
My father sorts by delicates.
Oh, boy.
And going back to the camping thing, I have my dad's in my room there.
Yeah.
I have this hamper and it's one of those pop-up style.
Mhm.
Collapsible.
Yeah.
And then it looks a little bit like.
Yes, I know exactly what you're talking about there.
And I probably had that same one for like 10 years.
I'm proud. I'm glad some of us use baskets. You will make your lives easier by using baskets. Good. That I'm glad to hear. Anyway, I guess that kind of backfired on me. My whole point is, do you guys know what sorted means?
Yeah.
What would the rocks look like at the bottom of the hill if they were sorted? What, a bunch of what? They could be arranged, largest to smallest. Or there might only be small sediments if they were sorted, or there might only be large sediments if they were sorted. My point of this whole conversation, which absolutely backfired on me, is sorting means arranging by a particular observation, whether it's by size, color, delicacy of the or how delicate, not delicacy, no one's eating clothes, how delicate the fabric is or whatever. So hopefully we now understand, and or maybe it did in the first place and I shouldn't have even talked. What kind of drawing do you think gravity erosion deserves? Gravity. We've only done gravity so far. Yeah, absolutely. First thing I'm going to do is I'm going to draw a hill. Okay, a hill. Yeah, a picture. And what should the sediments at the bottom of the hill be? Jumbled. What is that vocab word that means jumbled? No. Unsorted. And then the other thing is, I would like you to be able to see that at the bottom of the hill, they kind of make an angled, like little slope. And so what I want you to at least be able to show in your, oh, you know what? They should also be angular. They don't have to be perfectly angular, just have some sharp corners on them. All different sizes, not round. Some of them might have gotten rounded, but most of them are just a jumbled mess. And you might even have some specks in there. So a couple of things. This is called a talus slope. So that hill that's kind of not as steep at the bottom of a cliff is called a talus slope. And they are unsorted, angular sediments. So if you can't tell that from your drawing, like you might not be able to tell from mine, that's a talus slope. They're a pile of unsorted angular sediments at the bottom of a hill. Yeah, you're right. Mine is just a mess. It's unsorted. You're right. Hey, be quiet. I always eventually fix it. Yeah. I didn't think Sean was going to give it to me too. I expected it from you, but not Sean. All right. Are you saying I deserved it? All right. I guess we'll move on. Let's go. Let's see what's next after this slide. Yes, wind. Guys, how does wind move sediments? Picks them up with its hands. Blows them around. What size sediments does wind carry? Small. What are some things you've seen the wind carry? Sand. Dust. Grass. Leaves. Snow. Okay, so you guys all described some small things, but then I think jokingly in the background, someone said a house. Okay, but all joking aside, can wind move a house? Yeah. When? A tornado. So what's the difference between the wind today and the wind in a tornado? A tornado, the wind is a lot faster. So, say it again. I cut off your first part. What did you say? Right. So we've got some wind can just carry around little stuff, but big wind can carry around big stuff. So what do you think is one thing that's going to be different between wind and gravity erosion that we just talked about? Because now it's sounding like the wind cares about size, right? Not cares, but with gravity, did the size of the sediments matter? But does with wind, does the size of the sediments matter? It does. Now, when does wind drop off sediments? When it stops. Now, does it have to stop to drop off the house? No, it just has to slow down. So wind will drop off sediments according to their size. The biggest sediments in that tornado will get dropped off before the smallest sediments. So in this case, what's different? Out of the stuff we just spent some time talking about with gravity, what's going to be way different with wind? Okay, it is a natural disaster, no doubt, but of the stuff we literally just talked about with gravity, what's now going to be? Now it's going to be sorted. Wind actually sorts sediments by their size. If that tornado, have you guys ever seen the movie Twister? It's old, but I think pretty good. It's just like what? No, it's nothing like playing Twister. So Twister is a movie. It is from like when I was your age, so it is really old. But with Twister, it was a really huge tornado, and they were trying to put scientific material or like data collectors inside the tornado. And to do that, they had to get really close to these really big tornadoes. So with Twister, there was one tornado that ripped through when they were out there trying to get to it. And at one point, my favorite part is it picks up a cow. And the cow is going around. And not that that's good that it picked up a cow. And that's not why it's my favorite. But they go, cow. And then they go, another cow. But it turns out it was the same cow. And it was funny. I guess I had to be there, or not be there, but at least watch it. And then it also had a semi-truck, tanker truck in it. And then it also ended up having parts of a house in it. So as that tornado slowed down, the path of debris that was left was organized by size. First, there was the house, then there was the tanker truck, and then there was the cow dropped off. So that was the tornado sorting by size. As it slowed down, it dropped off the biggest, heaviest things first, and the smaller things later. So tornadoes and wind does sort by size. There's also some other gravity erosion or wind erosion. Again, you don't need to write until the end, but what we got going on here is normal everyday wind can pick up clay, silt, and sand and move that material around. So on a daily basis, the wind is only moving teeny tiny things. But as we talked about, stronger wind does mean more erosion. We will typically see wind erosion happening in places, again, still don't write. We'll typically see wind erosion in places that have a lot of little material, like a desert or a beach. These are more typical places that have those small sediments. When that wind blows, it will pick up and move away the small stuff. So we could end up with this process called deflation. It's the removal of the loose, fine-grained sand. So at a beach or at a desert, there is all sorts of sediments, but the only thing the wind's going to move is the small stuff. So eventually all the small stuff is left or is gone, and you're left with only the big materials. This is called deflation, removing of the sediments. But what's left is what's called desert pavement. It's called desert pavement because what's left is almost like somebody purposefully put a bunch of sediment down, almost like pavement. So the only thing that's left are those big hunks of gravel, and it kind of acts like a gravel driveway or a gravel road. That's called deflation and desert pavement. We'll also get abrasion. If you guys remember, abrasion is the bumping and rubbing of rocks. But in this case, it's not rock against rock. It's sand against rock. So in a desert, all day, every day, that sand is getting blown around. Have you guys ever been at a beach when it's windy and felt the sand hitting you? Can you describe it? Or you want me to? It doesn't. Did you say it doesn't feel nice? Who said it? Yeah, it doesn't feel nice. It feels like literally sand blowing on your legs at a very high speed. It feels almost like little needles if you're there long enough. So that sand, even though it's teeny tiny and isn't doing much damage each time it hits the rock, that sand acts like sandpaper over time, and it will wear away the side of the rock that it's hitting from. Now, typically, wind usually comes from the same direction every day. Wind does not usually change direction. So since that wind is hitting all day, every day on this side of the rock, that side of the rock will get worn down. It'll become really smooth, and you can then be able to tell which side the wind is coming from. So if you only got this second half of the picture, the regents might ask you, well, which way is the wind coming from? It'll be coming from the left here, hitting the rock and wearing down the left side of the rock. So that might be a question they ask you about. This can create situations that look like this too. This is an actual rock in an actual desert. What do you notice that's weird about it? Yeah, it's really oddly shaped. This really skinny part is holding up this really big part. Why do you think the bottom is much skinnier than the top? The sand is constantly hitting the bottom. Wind is only strong enough to pick sand up so far. And so it is only able to hit the bottom of this rock structure. This is officially called a mushroom rock. I'm pretty sure you can tell why. Not super original in their label titles here. And these are super common out west, over in Arizona, Nevada, Utah areas, because the wind picks up the sand and hits the bottom, wearing away the bottom. What do you think eventually is going to happen to this? Eventually it's going to fall over, and then the whole process will start again on the top part of rock that's now on the ground. So this is just something that keeps happening over and over. The other thing that you will see a lot on beaches and in deserts are sand dunes. We don't have any like outside our window. We actually don't even have too many snow drifts today, but it's the same concept. So do you guys know what a snowdrift is? How does a snowdrift happen when there's drifting snow? The wind blows the sand. And what shape is a snowdrift typically? It is typically triangular, very almost identical to this snow or sand dune that's here. So what happens with a snowdrift, or we have a pile of loose snow? The wind is going to blow, just like I said, usually startled me. So usually from the same direction. So the wind will typically, like in this case, be coming from the left, and it's going to blow the snow. The snow is going to go this way, but it's going to start to pile up, and it is going to make an incline. But then what happens to the snow when it gets to the top of the hill? It just falls down. So snowdrift and sand dunes typically, like Colton said, have this triangular shape. They're going to have one side be a gentle slope and the other side be a fairly steep slope. The gentle side is always on the wind side. So again, they might give you a picture like this one, where you can see a gentle side and a steeper side. They might then ask you, which way is the wind coming from? The wind is always coming from the gentle side towards the steep side. So that's a sand dune. Here's a picture of a real sand dune. So again, they might ask you which way the wind is coming from. So which side is the steeper side? Which one's the gentle side in this case? Okay, so hopefully, and this did cut it off, but hopefully you realized there would have been a lot more of this sand dune over on this side. So you do need to be able to identify which way the wind is coming from. So again, here's some examples of wind erosion. We've got that desert pavement, which is all the little stuff being removed, leaving behind just the gravel. We've got sand dunes, again, gentle side, steeper side. That's the basics of wind erosion. Here's the big ideas for wind erosion. So same deal. Wind picks up sediments and moves them around. Stronger winds equal bigger sediments. Do you want to add one more to this? Okay, sorry. What I do want to add to this, so since it is bigger sediments, this means sorted. Sediments get sorted by size. So what I do need you to be able to do for this chapter is if you see or read about a particular feature, like in this case, when I'm talking about a feature, if the Regents mentions anything about a sand dune, you know it will be wind. So I'm not having you take much notes on this chapter. But what I do need you to be able to do is make those connections. A sand dune, I want your brain thinking, okay, wind did that. If you see something about abrasion, you could be like, okay, I know wind can do abrasion. If you talk about the talus slopes that we talked about with gravity, I want your brain thinking gravity did that. So you don't have to know exactly what a talus slope is or exactly what a sand dune is, but you do need to know what agent of erosion created that. However, with sand dunes, you do need to be able to do one thing, and that's what I want to talk about in our sketch that we have here. And that is, I'd like you to draw yourself a sand dune. So remember, we've got a gentle side and a steeper side. If you want to label this sand dune, just in case you forget, label it a sand dune. And then you do need to be able to tell me which way the wind is coming from. So remember, the wind is always on the gentle side. I am going to add a second sand dune. I'm going to add this sand dune. What's different about the wind in this case? It's opposite. So don't just get used to them doing the wind going left to right. They can switch it up and make the wind go right to left as well. So wind is always on gentle side. I'm going to go ahead and add that note. Wind is always on the gentle side. Glacier erosion is next. This one has a lot of pictures. And a lot of like just random names of features that, again, when you hear this name, one of them is going to be a kettle lake. When you hear these names, you do need to then remember, okay, a glacier made them. So again, you don't need to know exactly what a kettle lake is going to be, but you do need to know what made it. Let's get started with glacial erosion. So I think I mentioned this yesterday. I don't actually know if I'm not sure if I did it with this class. What agent of erosion, remember the 5, wind, waves, running water, glaciers, and gravity? Which one do you think does the most erosion every day? Every day, like today. I'm hearing like, wind. What else do you think? Gravity. So I guess I'm asking, which one do you think moves the most sediments every single normal day? Wind. So you think if I made a pile of the sediments that wind moved, it's going to be bigger than a pile of sediments anything else moved? Wind, waves, running water, gravity, and glaciers. Think waves. So wind does move a lot of small stuff. Waves. Okay, so let's talk about running water. What is running water? Like a stream, like a creek, like a river, like the ditch in your front yard, like when you leave a hose on. Any of those things are running water. Think about how much of those things there are in the world. There's a lot. There is a... Right. But it only hits the coastlines. We're not affected by waves here at Pioneer. They don't bother us, but are we affected by glaciers today? We're not affected by glaciers. We're not affected by waves. How much wind erosion do we have here? Last weekend, a lot. When it was super windy, no doubt. But on an average day, we're not moving a lot of sediments around here. We have ways of protecting us against wind erosion. What do you think we do to protect ourselves against wind erosion? Houses will slow down. Putting stuff on the ground. Houses, even grass, is going to prevent us from losing sediments to wind. The roots hold it in. So we don't have wind erosion. We don't have much gravity or wave erosion. We don't have any wave erosion. We don't have much wind. How much gravity erosion do we have here at Pioneer? A normal amount. But how many rivers, streams, creeks, backyard, hoses, ditches are here? There's a lot. So guys, gravity or running water erosion is the #1 agent. It does the most moving of sediments in the world. However, glaciers, do we have any glaciers in the whole United States left? There's not a single glacier left in the entire continental United States. So today, glacier erosion's not doing much. But what was most of the country covered in during the last ice age? A glacier. Glaciers do a tremendous amount of damage when they're around. New York State, I like to say, was basically created by a glacier. The fact that, you guys know Genesee Road that goes like this, my whole ride to school, the reason it goes like this is because the glacier was there. The reason we have Holiday Valley, the reason we have Kissing Bridge, glaciers. The Finger Lakes, the Great Lakes, glaciers. So let me ask you this. Do you know how a glacier moves? First of all, do you know what a glacier is? Let's start there. Okay, it's ice. Well, how does it get there? Oh, it's not from the oceans. Huh? Okay, they do slide downhill, but where do they come from? Like, what is a glacier made out of? It's not really even ice at first. How does a glacier form? Snow. It's gonna snow. And snow. And snow. And snow. What's not going to happen to that snow? It's not gonna melt. Okay, so for whatever reason, the snow doesn't melt. So that's not us most of the time. But you know those snowbanks that last way longer than the snow on the regular ground? Why? What happens in those snowbanks? It does freeze. Once you've got one snowbank, what usually happens to that snowbank? It gets more compact. One reason it gets more compact is because they pile more snow on top of it. And it does get more compact and more compact. And it never melts. So let's picture this snow never melting. And then what's going to happen next winter? It's going to add more snow. That's how a glacier forms, is that more snow and more snow just compacts on itself. And snow can be heavy. You guys have shoveled at least once, I'm hoping, in your life. Snow can be heavy. And the more it snows, the more it's going to compact. Now, glaciers move. What are you noticing as I pile more snow on top of this glacier? What did you notice? It's moving outwards. So the more snow I pile on this and the more it gets packed down, notice how it's moving outwards. If I had something sitting there and I keep piling more snow on top, what did you just notice about the Play-Doh container? Oh my gosh, it's moving. That's how glaciers move. Glaciers move because gravity is pulling the snow on top down towards the bottom. It's compacting the snow, but it's also causing that snow to push outwards. So that's how glaciers can move. Now you just saw this Play-Doh move the Play-Doh container. What do you think actual glaciers can move? They could move literally anything that's in their way. It could move a building. It could move the grass and the dirt that's on top or that is right below it. So glaciers are very strong. I like to kind of think of them as bulldozers. So obviously I thought we'd be able to get through glaciers today, but clearly we did not. But then again, I got a little off topic talking about laundry. So no homework tonight. I'll keep you with no